All right, so 3 is called synthetic and long division. We're actually going to start with long division and then switch to synthetic division. So long division and synthetic division both allow us to divide polynomials. So we've done adding, subtracting, multiplying, right? We haven't divided polynomials yet. So that's what this is going to do. And we'll use this a lot. I promise this is not something that goes away anytime soon. You will use long division throughout this year, sporadically. You will use it again when you get to pre-calc. You're going to keep using it. This is one of those skills you'll use again. So it's, again, it sounds long because the steps seem tedious, and they are, but it's not horrible, and it's easy once you get the hang of it. You just have to practice it. So we start by arranging both the terms in the dividend, which is what you're dividing into. This is the dividend. This is the divisor. Okay, if it's written in a fraction, it's dividend over divisor. I'm not going to test you on that, but just know that when it gives you directions and stuff, it's going to use those terms. So you're going to arrange the terms of both the dividend and the divisor in descending powers of the variable, which means if I have like something like x plus 2x squared minus 1, I have to rearrange that so that the x squared comes first, then the x to the first, and then the constant. So you always want to rearrange them. You also have to check to make sure that there's no term missing. If I had an x squared, let's say I had 2x squared minus 1, but I don't have an x to the first, I have to add in what we call a placeholder, which is 0x. If I was missing the x squared term, if I had an x to the third and an x to the first, but not an x to the second, I would make it 0x to the second. So whatever is missing, you plug in a placeholder which has a 0 as its coefficient. Yep. That was like simultaneous. Yeah.
So you said plug into in the 0. Like, how do you know what is missing?
So you look for the highest exponent. That's the first thing you want to do. Look for the highest exponent and then put it first. And then if that highest exponent is squared, then I need an x to the first and I need a constant. If that highest exponent is x to the third, then I need an x to the second, an x to the first, and a constant. And if I'm missing any of those terms, we're going to plug in zeros.
And do you do plus 0? Oh,
it doesn't matter. Good question. It doesn't matter. The question was, is it plus 0? And it doesn't matter. You could do plus or minus 0 because it's 0. It doesn't matter.
So if you have like x, you see like 2x minus 1.
Then you're fine. That's technically the highest would be x to the first and then the constant. So you're not missing anything. Yep. So you have to do this for both what you're dividing into and what you're dividing by. So I'm going to check both. Okay. And again, if there's anything missing, I'm going to do it for both. I'm going to plug those in. Then just like if you think about long division with numbers. So if I was dividing 124, let's just make it easy, by 2. Then I would do 124 and I would divide it by 2. And I would take what's on the outside and divide it into what I can divide into first, right? We would say that's 6. We would multiply this. We would get 12. Subtract, you'd get 0. Bring down the next one, you'd get 4. That pattern is exactly the same. We just now have variables. So we divide the first term in the dividend, so the one on the outside. On the inside, divide the first term in the inside by the first term on the outside. The result is the first number of the quotient, so it goes at the top. We multiply that out. Now, previously we subtract, but the biggest mistakes I see in long division is if you're subtracting negatives. So my advice is to change the signs and add instead. So that's why that's there. We're going to change the signs and then add the like terms. And then we're going to bring down the next term and we're going to repeat it until the remainder can no longer be divided by what's on the outside. This is also when the degree on the remainder, degree is the highest exponent, on the remainder is less than the degree of the divisor. And I'll show you what I mean when I get to numbers. The answers will be written like this. The quotient, which is the thing at the top, plus the remainder over the divisor. And again, obviously we're going to work through several examples and I'll remind you of that format. So this slide is just to help you if you get stuck. Hopefully you don't need it, okay? All right, so we start with example 1. X squared minus x minus 2 divided by x plus 1. So check your numerator. Is it in order of decreasing degree? Yes. Is there any term missing? No. So I'm going to go ahead and I'm going to write that on the inside. X squared minus x minus 2 divided by, now look at the outside or what's on the bottom. Is it in decreasing degree order? Yes. Is there anything missing? No. So that goes on the outside. So I want to look at the first term and the first term. I want to ask myself, what would I have to multiply by x to get x squared? And it's what? X. So I'm going to put x at the top. Oops, not like that, with that. And I'm going to multiply it times both terms on the outside. So x times x is x squared, and x times positive 1 is a positive x. Then I said, normally we subtract here, but my advice is to, instead of subtract, change your signs and add, because it's the same thing, and it results usually in less mistakes. This should cancel. If you've done it correct, the first column will cancel every time. And then I have negative x minus x, which is negative 2x. I bring down the next sign, or next term, which is negative 2.
Wait, why did you put a plus?
So instead of subtracting, I change the sign and add. They are the same things. But what happens is people subtract negatives and they make mistakes. So I recommend changing your signs and adding.
So if it, let's say it was like x squared plus x, would you subtract an x?
So if my initial multiplication here was x squared plus x, and then we changed them all. So if you're saying instead of changing the signs and adding, you would just subtract it?
No, like if it was like a different original problem, like do you do the opposite all the time, or do you?
You always change the sign and then add it. Yep.
I'm just so confused how you got the x on the top.
I have to figure out what I multiply x by to get to x squared, or divide x squared by x. First and first.
And then why?
And then you multiply it times both terms on the outside.
And then why'd you subtract x squared minus x? Like.
So
That?
we change the signs and add.
No. How did you get that? Like x squared minus.
So we did x times x, which is x squared, and then we did x times 1, which is positive x. Yeah. So now I have to repeat that process again, first to first. So x now into negative 2x. So what do I have to multiply x by to get to negative 2x? Negative 2. So I do negative 2 at the top, and I multiply that times each of the terms on the outside. So negative 2 times x is negative 2x. Negative 2 times 1 is negative 2. Change your signs. Add them. First column cancels like it's supposed to. Negative 2 and positive 2 means I actually have no remainder this time. Yep.
So how come negative x plus x was negative 2x?
Because it was negative x plus a negative x. I changed the sign and added. We're going to do a whole bunch, okay? So this is my answer. X minus 2, and there's no remainder.
So that's not a plus.
Which one?
Like x squared and then it says plus x.
So initially we multiplied x by x and got x squared. Then we multiplied x by positive 1 and got a positive x. Then instead of subtracting, we are changing our signs and adding. So then it became negative. Does that make sense? And then it was a negative x minus a negative x. Vanessa.
So in the previous slide it said you write the answers as quotient
Plus remainder over dividend, and that is, or over divisor, and that's if you have a remainder. So we don't have a remainder, it would be plus 0 over the divisor, so we leave it like that. The next one's gonna have a remainder. Yeah. All right, let's do number 2. Look at the top. Is it in decreasing degree order? Nothing's missing, so that's gonna go on the inside. X squared minus x minus 2. Look at the bottom. Is it in decreasing degree order? Nothing's missing, so it goes just like that on the outside. So now we repeat this process. First into first. So what do I have to multiply x by to get x squared? X. I'm going to multiply that times both terms on the outside. So x times x is x squared. Positive 3 times x is a positive 3x. Now we change our signs. So it comes negative, and we add. X squared minus x squared cancels out, which is what it should do. Negative x minus 3x is a negative 4x. Then I bring down the next one, -2. With me so far? Good. Now, on the top, then I look at first and first again. So what do I have to multiply x by to get to -4x? -4. And I multiply that times each of the terms on the outside. 4 times x is a positive 4x. Or sorry, -4 times x is a -4x. -4 times 3 is a -12. Change your signs. Add. First column cancels like it's supposed to. -2 plus 12 is a positive 10. This time, I have a remainder. Yep.
So the first time you change the sign on the second term?
You change the sign on everything. So after you multiply what's on the top by what's on the outside, you change all the signs and then add them.
Okay.
Does that make sense?
Yeah.
Okay. Otherwise, they won't cancel. Yeah.
That's fine.
All right, so now I write this as quotient, which is x minus 4, plus my remainder, which is 10, over what I divided by, which is x plus 3. And this is the format of the answer. Questions so far? Obviously, it was coming, right? Bigger numbers, same exact process, no need to freak out. But look at my numerator. Is it in decreasing degree order? Yes, highest x1 is 3. Do I have a term there for everyone? Yep, still yes. Third, second, first, and none. So that becomes what goes on the inside, 5x to the third minus 6x squared minus 28x minus 2 divided by, look at the outside, or the bottom, in decreasing degree order. Yes, nothing's missing. So x plus 2 goes on the outside. Take it one step at a time. So first into first. What would I have to multiply x by to get to 5x to the third? 5x squared. And that gets multiplied by both terms on the outside. So 5x to the third plus 10x squared. Now I change my signs and add. Positive 5x to the third, negative 5x to the third cancels, which is what we're trying to do. Negative 6x squared minus 10x squared is negative 16x squared. Bring down the minus 28x. We bring them down one at a time. Yeah, good question. Now, first into first. What do I have to multiply x by to get to negative 16x to the second? Negative 16x. Now that gets multiplied by both the terms on the outside. So negative 16x squared minus, wait, hang on, sorry. Give me 2 seconds. I think there's a typo there. No, I'm good. Okay. Minus 32x. With me so far. Now, we change our signs.
Wait, how did you have to? Never mind.
You good? Yeah? Okay. First column cancels out. Negative 28x plus 32x is a positive 4x. And then we bring down the last term. And we do first into first again. So what do I have to multiply x by to get to 4x? Positive 4. And multiply it times each of the terms on the outside. 4x plus 8. Change your signs. Cancels. Negative 10 is my remainder.
Wait, where did you get the 4 plus 8 from?
I multiplied 4 times x and times 2. So this whole thing is my quotient this time. 5x squared minus 16x plus 4 plus my remainder, which is negative 10, over x plus 2. Now here's the only catch. If it's negative in the top, instead of doing plus a negative, we change this so that it is minus a positive 10 over x plus 2.
So it's always gonna be plus unless than a negative.
Correct.
And then, are we ever gonna, like, is it always gonna, like, be able to be subtracted? Like,
Yes.
is it ever gonna-
If it doesn't, that means you're missing your placeholder. So like that's why we do placeholders, because I can't subtract an x to the third from an x to the second. So we fill those placeholders in. So you might be adding zeros, but you're always going to have something to add. If you don't, you forgot your placeholder.
So we always change the sign, and then, cause like before we had changed the sign and subtract.
No, we change the sign and add. It takes the place of subtracting.
Oh.
Yep. Changing the sign and adding is the same as subtracting. It's just, in my experience, people make mistakes when they start subtracting negatives. They make less mistakes when they change the sign and add, so I teach it that way. But they are the same. All right. Look at my numerator. Is it in decreasing degree order? It is, but they're missing terms this time, right? So I have an x to the third, but I am missing an x to the second and an x. Those placeholders have to be there. Otherwise, when I go to add, they're not going to work.
Like, how does that work though? Because aren't you just like, oh wait, never mind.
You sure?
Isn't 0x squared 0?
It is. That's why we can do it. It's literally just a placeholder. So we are not changing the value of our expression in any way. We're just saying, I need something here because when I multiply this out, I'm going to have to add and it's not going to be a like term. So it is simply a placeholder. We're not changing the value, which is why it has to be 0. Like you can't put in x squared. It has to be 0x squared. Okay, then we're dividing by. Outside is in decreasing degree order. Not missing any terms. Otherwise, we would have done the same thing there. And we go first into first. So what do I have to multiply x by to get to x to the third? X squared. That gets multiplied by both things on the outside. So I get x to the third plus x squared. Change your signs. Add. These cancel like they should.
I'm just confused at the beginning. So you're multiplying both times.
You always multiply both. Whatever's in the top, you always multiply times both.
Okay.
Yep. And then I have a 0x squared minus an x squared, which means minus x squared. I bring down the 0x. And I do first into first again. So what would I have to multiply x by to get to negative x squared? Negative x. Repeat the process. Now multiply it by both of them. Negative x times x is negative x squared. Negative x times positive 1, negative x. Change my signs and add. First column cancels. 0x plus x is x. Bring down the minus 1. Last time, first into first. What do I have to multiply x by to get to x? Positive 1. Multiply it times both the terms on the outside. X plus 1. Change your signs. First column cancels like it should. Remainder, negative 2.
What did you put that final x minus 1 into? Did you?
The pink one or the purplish or the blue one?
Okay.
So what do you mean put it into? I look to see what I'd have to multiply x by to get to x, and it's 1. So then I multiplied the 1 times all of them. So now my quotient has 3 terms, no difference, right? Just x squared minus x plus 1. My remainder is at negative 2, so I do minus 2 over x plus 1.
So are the 0x's like they don't have any value?
Correct. They are simply placeholders so that we add like terms.
So to like the second, I don't know what step it was, but when it was negative x squared plus 0x and then you added the x squared plus x, you just keep the x, it's not 2x.
Right, because it would be 0 plus 1, right? So it would be 0x plus 1x, which is just 1. Yep.
Okay.
So think about what would happen like if you didn't fill in those placeholders, right? I'd get x to the third. Whoa, let me do it in pen. X to the third minus 1 divided by x plus 1. I'd say I have to multiply by x squared. I'd multiply x squared times x, that's x to the third, plus x squared. I'd change my signs. This cancels, but then I'd go to add that, and I can't, right? So hopefully you catch it, but that's why you have to have the placeholders. Does that make sense? Yeah, okay.
Like for the denominator, if it wasn't like in the correct order and you're doing like the remainder, would you put the original or would
It actually doesn't matter.
okay.
Yeah, good question. It wouldn't matter. You can put it over the original or you can put it over the, it doesn't matter. Order there doesn't matter. It's just in order to divide it, it has to be in the right order. We good? Yeah? Okay, hard part was over. Good job. Yeah.
Are we gonna be able to finish this today?
We're going to. Yeah, remember they have mass. That's why we said we could do it today. Oh, yeah, you're with me for like the next half hour still. Yeah, that's the only reason why we said we could do it this way. Okay.
For just a second.
All right, synthetic. Remember I said easy, fun. I promised you. Maybe not the most fun you've ever had in your whole life, but fun. These is easy. Yeah, I'll show you. Because you get rid of variables and you just deal with numbers. Back to old school. We like that. Yeah. So this is exactly the same first step. Arrange the polynomial in descending powers. Make a 0 for any coefficient that's missing. Then, if the divisor is x minus e, which I'll kind of explain when I get to numbers because I think it's easier, you're going to change the sign on what you're dividing by and put it on the outside of this little box that you're going to make shape like it. Some people do it that way and some people do it the other way, but they're going to make it an L. You're going to put c on the outside here, and you're going to put only the coefficients of what you're dividing into inside the box. You're going to bring down this first term. You're going to multiply what's on the outside by that term, and you're going to put it in the next column. You're going to add those, and then you're going to repeat the process. Multiply what's on the outside, bring it to the next column. Add, multiply, put it in the next column. You're going to repeat until all the columns are full. The last number on the bottom is your remainder. And then you work your way back up with your x values. Again, super easy to see it, a little bit harder in words, but I want you to have these words so that if you get stuck, you come back and you say, oh, that's what that step was. Okay. Looks the same, right?
Wait, can you go back?
Mm-hmm. Okay, so it looks just like the other one, and sometimes you will have the choice between synthetic and long division, and I would always choose synthetic. You cannot do synthetic if it is not just an x plus or minus a number in the bottom. So if what I'm dividing by is x squared, I cannot do synthetic. If what I'm dividing by is like 2x plus 1, I will not do synthetic. I will only do synthetic if it's an x plus and minus a number. But if you get the choice, shoot, pick synthetic, because I'm about to show you it's a lot easier.
What if there's no x?
You can't divide. Yeah, you won't do it. It has to be some sort of x. I mean, you can, but it's just, you just be simplifying. Yeah. Okay, so look at my numerator. Is it in decreasing degree order? Yes. Am I missing any terms? No. So instead of writing that whole thing out, I only write out its coefficients. So what's on the front of the x squared is a positive 1. What's on the front of the negative x is a negative 1. And then the constant by itself is negative 2. So I have taken away the variables. Then I draw my long L-shaped box. And I put the opposite of what follows x here on the outside. And this avoids our subtraction step. Now we always add. So we change the sign there so we don't have to change the sign every time. So opposite of what follows x goes on the outside. Now I bring down the first term. It's a 1. I multiply what's on the outside by what's on the bottom. Negative 1 times 1 is negative 1. And I put it there. Multiply by what's on the outside on the bottom and put it in the next column. Now I add. Negative 1 and negative 1 is negative 2. Multiply by what's on the outside. Negative 1 times negative 2. Positive 2. Add. And I get 0. 0 is my remainder. And then these, the first number on the right is my constant. The second would get the x to the first. If there was more, I'd build up as I go. So my quotient is x minus 2, and there is no remainder. So the last number is always my remainder. And then as I move to the left, the first number doesn't get a variable. The second one gets x to the first. If there was another one, it'd get x to the second, x to the third, and so on and so forth.
Where did you get the x minus 2?
So this is my remainder, right? This stays as a number. This gets the x to the first. If there was more columns, then it'd be x to the second, x to the third. That's one way to look at it. The other way is that this will always be one less exponent than that.
I don't know.
Whatever variable is going here will always be one less than the exponent on the first one. So it's called decreasing at a degree, but it goes from x to the second to x to the first. We're going down a degree.
Is this answer different than what we would get if we did long division?
Very good question. No, we already divided this and got the same thing.
Oh, okay, so let's just say that instead of that would be 1, it was 2. Maybe 2x minus 2?
Correct. Yep.
What if the remainder was like 1? Would that be like the...
So that would be the top of your fraction. Because look, we're going to do it again, and this time get a remainder. Yep. We're gonna do it again. I promise you we're gonna do synthetic division like 800 more times. Yeah. It's gonna click. It can't not click. It's gonna click. It has to. Yeah. Yep. All right. X squared minus x minus 2 over x plus 3. So in decreasing degree order, yes, not missing anything. So let's list our coefficients. 1, -1, -2. We good so far? Do we understand the coefficient part? Yeah, okay. Now the L comes. The outside of the L goes what? Opposite of what follows the X, so -3, good. Step 1, bring down the 1. Then we multiply what's on the outside by the bottom. -3 times 1 is -3, and we put it in the next column. And we add -1, -3, -4. Then we multiply what's on the outside by what's on the bottom. -3 times -4, +12.
Where did you get the -4?
Added -1 and -3.
Oh, okay.
Add -2 plus 12, 10. That is my remainder.
Why
That-
wouldn't you multiply the -3 times 10?
Because we're done. There's nowhere else to put that. So when you get to that last column, that is your remainder. There's nowhere else to keep going. So that's the remainder. -4 does not get a variable. 1 gets the x. So it'd be x minus 4 plus 10 over my divisor, which is x plus 3. Okay, again, we already did it, right? So we know, hopefully we know the answer. We're going to do it again. Decreasing degree. Yes, nothing missing. We're good, right? The coefficients. 5, -6, -28, -2. Draw your L. What goes on the outside? -2. Bring down the 5. Multiply the 5 by -2. Put it in the next column. Add -16. Multiply -2 times -16. +32. Add 4. Multiply -2 times 4, -8. Add -10. Here's my remainder. Moving left, the 4 does not get a variable. The -16 gets an x to the first, and the 5 gets an x to the second. So this is 5x squared minus 16x plus 4 minus 10 over x plus 2. Yep. Sure. Now we're going to do it synthetic. What's different with this one? You're missing terms. So I'm missing a 0x squared and a 0x. So I'm going to do 1, a 0 for the x squared, a 0 for the x to the first, and a negative 1 at the end. Draw your L. What goes on the outside? Negative 1. Bring down the first one. Multiply. Put it in the next column. Add it. Multiply. Put it in the next column. Add it. Multiply. Put it in the next column. Add it. The last number is your remainder. Moving left, the 1 stays a 1. The negative 1 gets an x. The positive 1 gets an x squared. And I get x squared minus x plus 1 minus 2 over x plus 1. I feel like they're watching Charlie Brown Thanksgiving next door. They're having so much more fun than you guys. I'm very sorry. Right? Do you hear the music? Yeah.
I'm confused as to how you know where to put the x's and which the x.
So there's two ways to look at it. One is the column all the way on the right is always going to be the remainder. Then the next column is always the constant, the one that doesn't get a variable. Then moving to the left would be x to the first, then x to the second. If there was another term, it would be x to the third. So we increase our degree as we move to the left. God bless you. The other way to look at it is the first term will always be one less exponent than what we divided into. So we divided into an x to the third. So the first one is x to the second, then it decreases, x to the first, then no x, then the remainder. So you just have to figure out how you see it. Is it from right to left building up, or is it from left to right building down? You're welcome. All right, last one. You want to race? Just kidding. I'm just kidding. How, if you could choose, what would you do? Can you choose that? Mm-mm. How do you know? Has an x squared. You can only do synthetic when it has x plus or minus a number.
Wait, if it was just 2x minus 3, you couldn't do that?
No, it's really wonky. You're dealing with fractions on the outside. You don't want to do it. Yeah, and it can be, sometimes they can be simplified, sometimes they can't. It's really wonky when you do fractions. So you're forced into long division. Does that make sense? Okay, so let's do it one more time. Let's get it over with. And then let's move on. So nothing missing from my first term. Everything in decreasing degree order. I'm going to work it through while you work it through. See if you could do it without me.
Miss Crystal,
Yep.
may I switch devices really quickly?
Sure.
Thank you.
You're welcome. When you can't multiply this by something to make it this. Like there's nothing, I mean, I can, it's a negative exponent. We're not doing that. I cannot multiply something by x squared to get to x. So when the exponent on the remainder is smaller than what's on the outside, you're done.
I'm confused because I thought you could only bring down one at a time.
So this, we did bring down.
Like for when we brought down negative.
Oh, because this has 3 terms, we always need 3 terms. So before we only had 2 terms on the outside. This time we have 3, so we need 3 terms. So you would bring them both down. Sorry, good question.
So basically, it's however many terms on the outside is however many terms you bring down.
Correct. Otherwise, again, you won't have something to add or subtract to. And you'd be stuck. Okay, questions on long division again before we move on? Sure. So again, if you have the choice, make it. Do it whichever works for you. I would assume most of it would be synthetic. But if you don't have the choice, you need to make sure that you know how to do both. And guess what? You're not going to have the choice on the test. You're going to be forced to do both. Yeah, well, it's so important you have to, because there's times that you have to do it. Like when we get to, well, you don't even worry about it yet. I promise you'll have to use it. Good. Should hit record. Let's say I asked you to find f of 2. So prior to today, if I had asked you to find f of 2, and I gave you, oh, we're moving so slow, there's such a lag. Okay. If I gave you f of a value, how would you have found that? Plugged it in all the x's, right? Which is still a valid way to do it. Now we're saying the other thing I can do is use synthetic division by putting that number on the outside, and then the remainder is the same as what I would have gotten if I had plugged it in. So we have another option. I don't know that. So we took the -2 for the first one, put it on the outside, did synthetic division, found the remainder was -9. That is your answer. And then we took 4, put it on the outside, did synthetic division, and the remainder is 396, and that is the answer. Still okay, right? Okay. Now we have something called the factor theorem, okay? I feel like everybody has PTSD from geometers too, and when they like see the word theorem, they're like, ah! It's not like that, okay?
We don't have to do like proofs.
No, there's no proof. No, a polynomial f of x has a factor x minus k if and only if f of k equals 0. I feel like my job as a math teacher is to translate between math speak and actual normal conversation. All this means is that if the remainder is 0, whatever we divided by is called a factor. And think about that. You already know, like if I said is 2 a factor of 10, the answer is yes, because 2 divides evenly into 10, right? So now just think about it in terms of an expression. If x plus 2 divides evenly into something, it means the remainder would be 0. That's all it means, okay? So that's what this means. So if you're given, yep.
And what was like the step? Because you said like if the remainder is 0.
If the remainder is 0, then whatever we divided by is called a factor.
Factor of what?
A factor of what we divided into. So if I had x squared minus 1 divided by x plus 1. I know this is going to work because that factors, right? Like that works. If I had actually worked that out, my remainder would have been 0. Okay? So this is called a factor of this
Oh.
because the remainder is 0. Does that make sense? And vice versa. If I say that is a factor of the initial one, then you know the remainder would be 0. So the way this is applied is really what this says. I'm going to give you a solution to a function. I'm going to say, here's a function, right? F of x equals blah, 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 blah. If x equals 2 is a solution, find the additional ones. And the way you do it is you use the number I give you on the outside of synthetic to reduce your function a degree. It goes from x squared now to x, or from x to the third now to x squared. And then you can use the quadratic formula or factor to find the remaining roots. So we use the given root to reduce it a degree to the point that we can either factor or use quadratic. Okay? Again, I walk you through this process, but that's it in words. So number 12 says, just determine if this is a factor. So how do I know if x minus 12 is a factor?
If it has a zero.
If the remainder is 0. Remainder 0, it's a yes. If it's not, it's a no. Easy stuff, right? Can I use synthetic on this? Heck yes, I'm going to choose that over long division. Can you use both? Sure. But I'm going to choose synthetic. So what goes on the outside of the box? 2, opposite of the sign because it's followed by an x, or follows an x. Then this is in decreasing degree order. 2, 7, -4, -27, -18. Bring down the 2. Multiply it. Put it in the next column. Add it. Multiply it. Put it in the next column. Add it. Multiply it. Put it in the next column. Add it. 9. Multiply it. Put it in the next column. Add it. Remainder 0. My answer here is yes.
So just if the remainder is 0, it's a factor.
Correct. Yep. And if it's not, this should be -6, then it's +18, then it's 0, so this is also yes.
Positive six. Oh.
Yeah. So I'm glad it happened because we need to see what would happen if it did. If it was a no, it would be anything but. Thank you, Juliana. But if it's still a 0, then it's still a yes. Which means you can have more than one factor, obviously, of an equation, which is what leads into the last application of this stuff. So this, yeah, question, and I'll work it through like step by step on the video, but I want you to get an understanding of it. Says, given that x plus 3 is a factor of f of x equals x to the third minus 19x minus 30, find all the factors and zeros. So what we have to do is use this to decrease this a degree. So I put a -3 on the outside. This is missing an x squared, so I get 1, 0, -19, -30. I bring down this 1, multiply it, add it, multiply it, add it, multiply it, add it. This has to be a 0 because it's already telling you it's a factor. And then I take the quotient, which is what I get as this answer. And anything that is quadratic, meaning raised to the second power, can be solved. I can either factor this, use the quadratic formula, okay, if it's not factorable. This one is. So my answers are all those factors, which would be, because it says find all factors, the -3 they gave me at the beginning, the -2, and the 5 I found by factoring my answer. So the first factor they give you, you're using to reduce it a degree, which makes it squared. And from there, you know how to solve it because it's quadratic. I will graph this last one on the video so that you can see what it looks like on a graph. Obviously, when we come back, we'll do more with graphing calculator. But you need to understand up to that point.
Let's say the answer was.
Okay, so what I did was graph this using the app. I typed in x to the third minus 19x minus 30, and then I hit graph, and I got this graph. So notice that if they are real roots, like these are all real roots because they're real numbers, you can actually see those roots as they cross, as the graph crosses the x-axis, because they would also be a 0, which is the same thing as an x-intercept. So here I've got -3, here I've got -2, and here I've got 5. So you can actually find real roots from a graph by identifying the x-intercepts.